do the homework. Okay, we got some questions on homework.
Yeah, it's only like 2 or 3, so don't worry.
No problem, don't worry. Oh, trig 4a, right?
Yes. And if you need
Those.
I think
Sorry.
it's on 61, I think.
No problem, we can do many. So trig 4a, okay, when I put on the homework, I'm asking you specifically to do it using ARD. Because the purpose of these homework is to reinforce definition. I know you guys all have your own special tricks to do it, but I insist you guys do it with ARD.
Okay.
Okay, so I'm going to show you how to do that. Okay, and of course you have to make sure you get the radians, right? A lot of you are used to the degrees, and I'm going to twist your arms to make you get used to the radians. How about that?
Okay.
Because you have to. Okay, so let's talk about ARD. Is there any particular one you want me to do?
Can you do question number 21?
Of course. 21.
Yeah, do you want me to tell you what it is?
I got it.
Okay.
21. We want to have the value of tangent 7 pi over 6. 7 pi over 6. Okay. The way I want you guys to do it, okay, I'm going to bring back that picture I drew before, right? This guy. Okay. I want you to do it with ARD because all of these exercise is reinforcing ARD, which is the centerpiece of this course, okay, of trigonometry, right? So you first look at 7 pi over 6, right? I look at 7 pi over 6. And I'm going to measure the angle from standard position, right? So this is a positive angle, right? There's no sign in front of it. That means this angle is measured counterclockwise, okay? So of course, where does it end up with, right? I can do a little, it's not entirely necessary, but it would help if you just break it up, right? 7 pi equals to 6 pi plus pi, right? So this way I will have a pi plus pi over 6. You don't have to do this, but do this a little bit helpful in terms of measurement. Pi is 180 degree, right? Pi over 6 is 30 degree, right? So when we do the A part, we measure from the standard position and we go counterclockwise. This is a pi and then pi over 6. Okay, so my terminal is going to be over here. And what will be my reference angle? My reference angle is going to be this guy. So my reference angle is what? What is my reference angle? Pi over 6, right? So my reference angle is pi over 6. Okay. And then by definition, so I got my angle, I got my reference angle. This is A is done, R is done. You guys see that? So A is done, R is done, right? So we done A, right? Counterclockwise measurement. Okay, and R, the reference angle is pi over 6. Okay, you can see, I want you to make these points go through your mind. Definition, tangent definition, to get the definition, there are multiple ways to do it. Okay, suppose I just follow the definition. I'm going to pick a dot. I'm going to pick a point on the unit circle arbitrarily. Remember, this point is picked arbitrarily. I can totally pick a point on the unit circle, can I? Right? Or I can pick anywhere. I really can pick anywhere. So I pick this point. Okay? Suppose I really just pick this point arbitrarily, and I need to figure out what is the x, what is the y, right? What is the x, what is the y? Because in the definition, I will need y divided by x, right? And the definition tells us any pair of x, y on the terminal except the origin will give us the right number. Okay, so let's figure this out. Together. Okay, so what I'm going to do is I'm going to draw the terminal. Okay, I want you to do that too. So this is just how we wish that to be don't worry about how I get these points, okay? It's just something, you know, right now I just want to make sure I have the right drawing. Okay. So suppose that I'm going to draw this point. That's a terminal. I can make it longer. Right? So that's the terminal. I'm going to pick arbitrarily any point. So we still use the definition because I want you guys to learn to appreciate the definition. Okay. So what I would do is that I'm going to do, say, just 10 times that. And this is 10. So that way I get the terminal. I got the terminal, right? You know, I was just using that software. You don't have to worry about. So we get an A, we get an R, right? And next we're going to pick a point arbitrarily. I'm going to pick this point arbitrarily here. That's my XY. Okay. What I do know that my X will be this guy. Yeah, this is my X, right?
Mm-hmm.
That's my Y. Yes, that's my Y, right?
Yeah.
I don't know what they are. Pretend I don't know what they are. So this is X, this is Y, and that is X. I'm following the definition. So how do I figure out this point? Right? Knowing that this is pi over 6, knowing this angle, this reference angle is pi over 6. And I would know because this make a right triangle, right? What angle would this be? Pi over 3, right? 60 degrees. 30 degree, 60 degree right triangle. Okay, you follow me?
Yes, kind of. I'm seeing it though.
Kind of. Okay. So whatever gap there is, I'll fill it. For now, we just know this triangle because this is a 30 degree, which is pi over 6. I know there's a lot of information if you haven't done this for a long time, right? So this is a 30 degree. 30 degree is pi over 6. And the angles of a triangle add up to be 180 degree. You understand that, right?
Yeah.
So this is 90 degree, 30 degree. So this has to be 60 degree, right?
Okay.
60 degree is pi over 3. Okay. 60 degree is pi over 3. This is 30 degree. Okay. And the other angle is pi over 3, which are complementary to each other. And this is really
60 degrees.
60 degree. Okay.
So
If you have trouble converting these, getting used to this, that will take time. I'll come back to go over this. So what you see is you see this triangle, and you see this is 60 degree here, and this is 30 degree here. So if I would just take this triangle, right? And at this point, I want to figure out what is x, what is y, right? We know x is negative, y is negative, right? Because this point is in the third quadrant, right? So x itself is negative, y itself is negative. All I need to do is figure out what is x, what is y, yes?
Mhm.
There are more than one way to do this, but I'm doing this from definition, okay? I'm from definition. Now, with this said and done, if you look at this triangle, what I would do is I'm going to mirror this triangle over this line, over the horizontal line, okay? So there's a triangle. So I'm mirroring this triangle, right? I'm mirroring this triangle over the x-axis. Okay?
Okay.
So this triangle, we have a 60 degree here and 30 degree here because it's just a mirror. So therefore this piece is also 30 degrees, right? This is also 30 degrees, right?
Yes.
30 plus 30 is 60.
Yes.
60 degree, 60 degree, and this angle has to be 60 degree, right?
Yeah.
So this is a unilateral triangle.
Wait, say that one more time.
Unilateral triangle.
Okay.
You know what's unilateral triangle?
No, I actually don't.
Every angle is 60 degrees.
Okay.
Okay, every angle is 60 degrees. Okay, what's so special about unilateral triangle? Unilateral triangle, every sides are the same. So 60 degree, 60 degree, 60 degree. And every side, they all have the same length. Therefore, if this is R, right, if this is R, hypotenuse is R, and this is R, and this whole thing is R. Do you see that? Yes?
Yeah.
And the Y, which is here, Y, this is a Y. This piece is a Y. This piece of Y is half of R. Do you see that?
Yeah.
Okay, if this is half of R and this hypotenuse is R, we can find the other leg, can we? Using Pythagorean theorem, right?
Mm-hmm.
Okay, so using Pythagorean theorem, okay, we have one side, so one leg is half of R, right?
Yeah.
Hypotenuse. So let's say I'm going to call this A equals 2, right? This one leg, right? And I'm going to call this side X, right? This is X, right? We don't know X, but I know that this side, is it earthquake? This side is half of R, right? So Y is half of R. Okay, I would say Y is half of R, right? Because this is in the third quadrant, this is going to be negative half of R, right? Because R is always positive, right?
Yeah.
Now, the hypotenuse, hypotenuse is R, right?
Yeah.
So what is X? x is the other leg, right? So we know this side is r, right? This side is r, this side is r, right? This side is half of r. So this side is negative r divided by 2. So we want to find this side, which is x. Do you follow me? And
Yeah.
this is the right triangle. This is right triangle. Okay. So
Okay.
now x squared would equals to half of r squared plus r squared, right? Yes?
Yeah.
No, sorry. My bad. X squared plus half of r squared equals to r squared. Pythagorean theorem, right? This is one leg squared and the other leg squared equals to hypotenuse squared, right?
Yeah, but what happened to the 2 on r over 2?
Well, you find out. You understand this, right?
Yeah.
Pythagorean theorem, right?
Yes.
So now we're going to solve for x. So we're going to take this guy, solve for x. Okay?
Okay.
Solve for x. Okay, which is this side, on this side. Okay? Now, I will bring the back. I'll redraw this picture again. So now you're gonna do x squared plus you square r over negative r over 2. That's gonna give you what? That's gonna give you r squared divided by 4. That equals to r squared, right?
Well, where did the 4 go?
We're going to subtract on both sides of r squared over 4, right? So if we have x squared, that equals to r squared minus r squared over 4. And then you're going to find common denominator, yes? Yeah?
Wait, sorry, I'm clearly trying to understand what you just did right now.
Subtracting r squared over 4 on both sides.
I see. Okay, sorry.
No worries. And this r squared minus r squared over 4. In fact, I can factor the r squared if you want, but let's just keep it simple, right? So I make the same denominator. You see that?
Mm-hmm.
I make the same denominator. And then we get what? Denominator will be the common 4. 4r squared minus r squared, that's a 3r squared. Okay?
Okay.
In this case, we understand r is positive already.
Yes.
Okay? R is positive. Okay, the way is being chosen. We just consider r as a positive. Now, we got x squared equals to 3 over 4 r squared. And we're going to take a square root on both sides. Shall we?
Yeah, can you give me 1 second? I'm currently writing this down.
We're taking square root on both sides.
Wait, how did the r drop out of the fraction?
You can write it this way, right? Just like that, right?
So it's still in the fraction?
The same thing. They're the same thing.
Okay.
They are the same thing. Okay, just conventionally, we like to write it this way, separating the symbols with the numbers. These two are identical. Okay, is that something you get used to? They're the same thing.
Mm-hmm.
Okay, so after I'm doing this, I've taken square root on both sides. What do I get for x?
You get x is equal to 3r over 4.
On the one side, on the left-hand side, you had absolute value of x.
Absolute value, my bad, sorry.
Okay, that's okay. Don't apologize. But if you keep doing that, you're gonna lose a lot of points here and there. Okay.
Okay.
On the other side, okay, on the other side, the square root of 4 is 2, right?
Yes,
The
that's
square root of 3 is root 3. The square root of r squared
is just r.
is just
Or-
r because we specify r is positive.
Mm-hmm.
Okay, so now we haven't get x completely, right? We get an absolute value of x. But what x must be? Because x is a negative in nature. It's in the third quadrant. So x has to be negative root 3 over 2. Because the point is in the third quadrant. Okay, in the third quadrant, right? So this point you have chosen, this point we have chosen arbitrarily, right? The respective x, which is over here, right? Okay, this is the x. This is the y. Okay, when the point in the third quadrant, the x is negative, y is negative. Do you follow me? That's why the x down below has to be negative root 3 over 2. Yes?
Yes.
Okay, so now we got the x, y's, right? Arbitrarily. So now the green piece is negative. Well, that's too thick. The green piece we have, that's half of r. Right? The blue piece we have was a negative root 3 over r. Right? We just did it. Now, what's the definition of tangent? It's y over x. Right? It's y over x.
Mm-hmm.
Did you write that down?
Yeah.
Okay. So
Wait, I'm getting the graph currently. Give me just a quick second. I'm getting the graph right now.
Mm-hmm. So all these work over here is try to figure out if you choose arbitrarily a point. Okay.
Okay.
That is, 30 degree, 60 degree, pi over 6, pi over 3. And that triangle is a unilateral triangle. 3 sides are the same. So that's why this is half of the r, right? You got that. And now from Pythagorean theorem, we found this side combined with the rectangular system property. So this is a negative because it's on the other side of x-axis. And this is a negative because it's beneath x-axis, right? So negative and negative. So that's the point. So this xy point, see this point?
Is negative radical 3 over 2 over r.
Yeah, so the x is what? The x is negative root 3 over 2.
And then for the y, it would be negative 1/2, right?
That's right, negative 1/2 over r.
Okay.
We didn't do this on unit circle. Okay. We didn't
Okay.
do this on unit circle. We just do it arbitrarily.
Oh, I was gonna say like, why don't we just use the unit circle? Because in my head, I was thinking like, this is like my own process thing. Because like I was forced to memorize it because for an exam, so I just memorized it in my head already.
You already have you have those you have those unit circle numbers, right? Yes, you can go that way. You can go that way, but I'm not sure. I don't know your background.
Okay.
Okay. So this is what you use with definition. If you select that point on the unit circle, then r would be equals to 1. So you have a negative root 3 over 2 and negative half. You follow me?
Yeah, and then you would divide.
That's right. You divide y by x.
Yeah, to get negative 1/2 divided by negative root 3 over 2, and then
Right. So you can get a 1 over root 3.
and then you multiply that to put
You can rationalize it. So it's going to be root 3 over 3.
yeah.
Right. So now, since we have gone this route, let's finish, right?
Yeah.
So you wrote this down. Clean this up, right? So now we get to do the tangent. Tangent 7 pi over 6. Okay, so it will be the y over x. Okay, the y is negative root 3 over 2. So I will give you an alternative solution from your background. Okay.
Y was 1/2.
So this is r and this is a negative half.
Wait, I thought y was 1/2. I thought y was 1/2.
Oh yeah, that's right. Y is 1/2. My bad. Thank you. So this is root 3 over 2. Okay. And now you can see r and r reduced, right?
Yeah.
If we do it, if we do the way we did, right?
Yeah.
So the way I do it is kind of, I would say it's more of a classic way of doing it. But if you have the background you have, you don't have to do this. Okay, but I'm just gonna run it to the end, right?
Yeah.
So r and r canceled, reduced. So negative canceled. So you're gonna end up with what? 1 over square root of 3, which is a positive.
Yeah. Oh, I see why. Because both the 2's also cancel out too.
That's right. So
And then
that's in the end, you have root 3 over 3.
Could you? Oh, okay. I see. I see. Sorry. Let me just write this down a little bit so I know what I actually did in my head. Cancel these.
Okay. Now, if you are familiar with a unit circle, guess what? You just told me you're familiar with a unit circle, right?
Yeah.
Okay. You have that in your head, yes?
Yeah, I do.
If you have that, because some of our students have never taken Trig. Okay. So they don't have that unit circle in their head. I don't know how I can help them to survive this, but I'll do my best. But if you have that unit circle in your study, and what you do, the arbitrary point you choose is not going to be the arbitrary point I have chosen. You just make that point to be on the unit circle. Do you guys understand? Do you understand what I'm saying?
Mm-hmm.
So instead of choosing any places like what I did, you can just pick, hey, I'm going to pick that point on unit circle. That's okay. Because doesn't matter where you pick the point, the ratio is always going to be the same. You're going to get the same answer. So you may just as well pick that point on the unit circle. So that's the perspective I want you to understand. Okay?
Okay.
So you have that unit circle in your head. As a matter of fact, I brought that unit circle to the class, right? I forgot where I put it. Where did I put it? Not here. Maybe I bring it to the other class. Okay, but I'm gonna show it to you. Okay, I think because the next time we're going to cover that, right?
Mm-hmm.
So let me give you that unit circle. Wait. Yesterday. Okay, my other class is a little ahead of this. This is unit circle review you refer to, okay? Did you just tell me you're familiar with this unit circle?
Mm-hmm. I am.
Oh, wonderful. That's great.
Yeah,
Okay,
I had to memorize it for an exam. It was with points. So if I didn't get all the correct points off in the circle, I would actually fail the exam. So I had to memorize it. So that's a
okay.
plus for trig.
That's your story. That's your story from your trigonometry. But
Yep.
so there's certain benefit for doing that. But I do want you to use, if that's the case you have, right? You understand my situation because everybody has different background.
Mm-hmm.
If you have this in your head, the thoughts go through your mind would be, you would do the A. You say, okay, I'm going to measure from the standard position. So I'm going to end up here, right? That's your A.
Yeah.
And your terminal is going to cross over here.
Yeah.
On pi over 6. So your reference angle is pi over 6.
Which is 30 degrees.
That's right. So you already have the point. You don't have to go through what I did to get the point. You already have it.
Mm-hmm.
You know what I mean?
Yeah.
So all you have to do at this point is that you get your definition here, right? And your x is negative root 3 over 2. Your y is negative half. So you would just plug those in without the r. You follow me?
Yeah.
And you get the same answer.
Okay.
So with your trig background, it does help you because you didn't have to go the long way. But the long way will really help you enhance your algebraic skill. But
Okay.
you really don't have to. Do you understand what I mean?
Yeah.
But what I really want you guys to go through your head is run the definition in your head, right? A, R, and D. That's what I meant.
Oh, okay, I see. Because like when you were doing this whole entire R stuff, I was kind of getting confused a little bit. And then I started to realize, wait, it's kind of like the long way of doing the unit circle.
Right.
Yeah. Okay, I kind of see.
The long way has its own merit. And this is why, Jacob. You should not be surprised when I was doing this triangle. Some of our students probably have never seen this triangle. So as a teacher, when I try to take care of everybody, I basically take this opportunity to review geometry. You know what I mean?
Yeah.
And for some students, this might be necessary to review that geometry. Even you have forgotten, right?
Yeah, I forgot about it.
Now you've been refreshed about that.
Yeah.
Okay, but that the value of that unit circle is really to help us to understand the definition, which is A, R, D. When you have that unit circle, then you already have the point picked for you. Okay, but you will see on quiz number 10 that angle is not a special angle. So you are forced to use the definition over and over again, because I really want to nail the definition in your head.
I see. So basically doing the first part is going to help me with quiz 10.
Yes.
I see.
Yeah. Because next week, you're going to realize the value of the definition even more. Okay. So I will talk about this next week, you know, how you use it from the circle, from this unit circle that you have so well remembered. Okay. You know, bless your work. Okay. That's great. But some of students don't have this. Some of the students in this class, they haven't taken trigonometry. I do my best to accommodate them, but not only to accommodate them. I want you guys to thoroughly understand the definition,
I see.
which is overlooked by most of the students, including myself at the beginning. And after I start teaching, I realize the value of definition. As I'm teaching in the classes, there's not a single moment I should forget about the definition as a teacher. Then you know the value for you, right?
Yeah.
But anyway, it takes time for me to, to deliver the message to you. And it also takes a lot of time from your part and effort to really get it. It takes time. All of these takes time.
Mm-hmm.
But you're doing great, Jake. Do you have another question?
Yeah, I was gonna say if it was okay if we can do number 24.
Number 24. Okay, so with your background, right? So when we do number 24, number 24 is tangent negative, right?
Yeah.
Tangent of negative pi over 6. With your background, you have the unit circle in front of you. What you do is that you say, okay, let me do the A, right? So you're gonna do the A, right?
Mm-hmm.
A is about angle measurement. So what you do, you see a negative angle. So when you measure the angle, you're gonna go clockwise.
Yeah. So it should be around, it should be like 1/2, right? Positive 1/2.
Positive 1/2.
Or is it negative?
Just hold on. Okay, hold on to your answer. Okay, this is the A. So you've done your angle measurement. The next one you do is to do the R. What's the reference angle? So this angle is negative pi over 6, but your reference angle is pi over 6.
Okay.
These are the things I want you to go through your mind. Reference angle has to be positive. Okay, even though this angle is negative pi over 6, let me write it down, okay? This angle is pi over 6. I'm sorry, it's a negative pi over 6. Okay. Its reference angle is pi over 6 without the negative sign. Do you follow me?
Yeah.
Now, the terminal, you choose arbitrary point on the terminal. We got the terminal here. We got the reference angle here. Now, the arbitrary point, because you have this freedom to choose, you choose the point on the unit circle. So you choose this point, √3/2, because you already have this, right? In your study, right?
Yeah.
And negative half.
Okay, I see. So the outside doesn't change. It's just
So
the
this is X, this is Y. You see, I'm still want to get to the definition. And tangent is Y over X. And this is your Y, and this is your X. So your Y is, what is your Y? Your Y is negative half. Your X is √3/2. Did you get what I'm saying?
Yes.
And then you reduce. This time you're going to get a negative of 1/√3.
Yeah, because you get rid of both 2 and 2.
That's right. You multiply 2 on both top and bottom. You basically multiply by 1 using principle number 1, right?
Yeah.
So in the end, you get negative √3/2. The √3/3, sorry, √3/3.
Okay, and the way you would get √3/3 is by doing -1 on top and basically switching it to √3/-1 or negative √3/1, which still is the case.
You just rationalize it.
Yeah.
Rationalize it.
And you would do times 3, right?
You multiply root 3 over root 3.
You do root 3 over 3. Oh,
right.
yeah.
You use that principle number one more time.
Yeah, so you do root, so times. So this is 3 over root 3. Okay.
Right?
Yeah.
So all I'm asking you guys to do is, I know for some of you, if you have this unit circle, the answer is pretty straightforward. But I want the ARD run through your mind when you're doing this. That's all I'm asking for. And this practice, this mental exercise is going to be very, very important for you. Okay, so that's all it is. Some of you may not realize the value of it. And you're going to learn to realize the value of it.
Okay.
You know what I mean?
Yeah.
Do you have another question or more questions? Feel free.
I don't really have any questions. Those are the only two that kind of like were like that didn't really help or I didn't really understand.
Right. Now you got it, right?
Yeah, I'm trying to look right now to see if there's any other ones I think I can need help.
You should do all of these questions this way with ARD.
I guess another one would be number 36, because I know you have to go over 360, which is basically still just pi over 6, I believe.
Okay, so if you look at 36.
I don't know. I may be wrong. I need to check on that one. And this would be the last one. And this will be the last one because after that, I already did it and it makes sense to me.
Yeah, sure. 36. Okay, 36. 36. We have tangent 7 pi over 3. 7 pi over 3. Right? You know the journey you need to take. So if you have this, right, first your angle is 7 pi over 3. This is a positive angle measured counterclockwise, but you have to, you're going to do this, right? This is what I would do. I would do 6 pi plus pi. 7 pi is 6 pi plus pi, right? So over 3. So that will be giving me 2 pi plus pi over 3. You see that? Okay. But when I do that, when I measure the angle, I will start from the standard position, of course. I will measure, this is 2 pi and pi over 3. This is my angle. And the terminal is here. So the reference angle is what? What is the reference angle?
It should be 60 degrees, right?
It's pi over 3.
Yeah, pi over 3, my bad.
No problem. No problem. You just have to back and forth until you get used to it, okay? Its reference angle is what? Pi over 3. Pi over 3. Okay? Now, you pick a point. And you pick the point on unit circle because you have freedom to choose any point on the line. Therefore, you pick a point on the unit circle. Do you hear my argument? Consistently, I'm quoting definition. That's the way to learn mathematics. That's what I'm trying to tell you. Okay, so you pick the point, and the point, of course, is half root 3 over 2. And then you just go ahead with the definition, right? So you pick the point. With the point you pick is half, right? And the other one is root 3 over 2. Right? What does that tell you? Well, x is half. And y is root 3 over 2.
Yeah.
And then you just plug in those numbers. It's y over x equals 2. Y is root 3 over 2. You get what I mean?
Yeah.
and the other one is half. And you reduce it, your final answer is root 3.
Yep. Because 1 is just 1, therefore it's over just root 3.
Okay, that's the value of using ARD. You let this go through your mind, identify A, identify R, and use the definition.
I see. So the quiz, okay, I think I understand now, or I understand now still. So yeah,
There's more to be understood. Okay, we can dig out a lot more from the definition.
yeah.
Just stay on for next week and
Yeah.
longer.
All right, that's all the questions I really have. Thank you so much for teaching, Miss Wang.
No problem, my great pleasure.
All right.
Anytime.
I will see you on Monday.
Yes, I'll see you Monday.
Thank you. Bye-bye.
Bye. Great job.